Welcome to Mount Zion family. This is Deepa handling chemistry. So today we are going to know a new concept in chemical bonding, that is unit 13. So what it is means, it is nothing but Fajan's rule. Before we enter into the topic, I just recall what we have studied earlier. The first one is chemical bond. Chemical bond is nothing but it is defined as the force of attraction between the atoms that binds them together as a unit called molecule. And the next thing is types of chemical bond. Already you know there are different types of chemical bonding possible between atoms which make the molecules depending upon the type of the bond, they show the different types of characters or properties. Okay, so the types of chemical bond, two types. One is strong bond and weak bond. Yes, you are correct. And we discussed the characteristic of ionic bond and covalent bond, and we know what is ionic and what is covalent bond. Okay, so today we are going to know about a new concept. It is nothing but Fajan rule. You know, ionic bond is nothing but a combination of metals and non-metals. So metals combine with non-metal through ionic bond. So such type of compounds are formed, that compounds are called as ionic compounds. Okay, so a compound said to be ionic, it means when the charge of the cation and anion are completely separated. Okay, so if it is not completely separated, then it is not, should be comes under the category of ionic compound. So if you say any compound as ionic, the charge of the cation and anions, it is nothing but positively charged ions is cation and negatively charged ions are anions. So when the charge of cation and anion are completely separated, but in some cases the charges could not be separated. So this should be found out by Fajan, the scientist, in the year 1923. Through his X-ray crystallographic studies, he found some of the ionic compounds show covalent character. So who found this one? The scientist named Fajan. Okay, so in which year? In 1923. So he do one X-ray crystallographic studies. In that he found some of the ionic compound shows covalent character. So that he predicts some rules whether a bond is a ionic or covalent bond. So that rule is known as a Fajan rule. Okay, so in this what he said means the charge of the cation and relative size of the cation and anion. So he formulated the rule mainly based on the charge of the cation and the relative size of the cation and anion. So what he said means, in the first thing, when the size of the cation is small and that of the anion is large, the bond is more covalent character. What it is? When the size of the cation is small and that of the anion is large. So if the size of the cation is small and the anion size is large, means the bond is mainly covalent character. Okay, so are you able to follow me? If the size of the cation is small and that of the anion is large, then it is a covalent character. The bond is a covalent character. The second thing is, greater the charge of the cation, greater will be the covalent character. Greater the charge of the cation, greater will be the covalent character. Okay, so let us see these postulates in a tablet format. So it is, if according to Fajan's rules, if it is a low positive charge, then the compound is a ionic. If it is a high positive charge, it is a covalent bond. So if it is a large cation, it is an ionic. If it is a small cation, it is a covalent. If it is a small anion, means ionic. Large anion means covalent. Okay, so Fajan said that based on the charge and the size of the cation anion, he explained the chemical bond character, either be ionic or covalent. Okay, so if it is a low positive charge, means it is an ionic, or else it is a covalent. Similarly, if it is a large cations, means it is an ion, it forms a ionic bond, or else it forms a covalent bond. And the last one, if it is a small anion, means it is a ionic in nature. The bond is ionic in nature, or else if it is a large anion, means the bond is in a covalent in nature. So let us discuss with examples. For example, consider sodium chloride. You are all know. Well-known example, sodium chloride. So the it has a low positive charge. For sodium, the valency is 1, so it is easily gives one electron and forms a single valency, low positive charge, plus 1. Okay, so a fairly cation, a large cation and relatively small anion. Okay, fairly large cation and relatively small anion make the charges to separate completely. So it is the ionic. So sodium chloride compound is the ionic. So just now we discussed in the table, if it is a low positive charge, if it is a low positive charge, it is a ionic compound. Okay, similarly small anion and large cation means it is a what it is? It is a sodium chloride is a ionic in nature. The second example is aluminium triiodide. So aluminium, what is the valency of aluminium? It is 3. So it is a higher is the positive charge. So if it is higher in positive charge, automatically it form a covalent bond. Okay, so if it is a low positive charge, it forms a ionic bond. If it is a higher positive charge, it forms a covalent bond. Okay, let us illustrate with one example, aluminium triiodide. See here, aluminium is in the center. It has a 3 valency. This 3 valency should be satisfied by 3 iodine. Okay, so it forms aluminium triiodide. 3. Okay, each iodine atom shares one electron and form a covalent bond with this. Okay, so aluminium triiodide is formed. Okay, this form is this is an ionic bond which was formed by transfer of electrons from aluminium to iodine. Okay, so aluminium iodide is an ionic bond, but when compared to the size of the iodine, see here, so what will happen? The size is too large. Okay, the anion size is too larger anion. Okay, thus the bond it shows a very less effective nuclear charge. So in the nucleus should be present at the center. It could not be pulled out the outermost valence electron because the size of the iodine is too large, so that the bonding electrons are attracted lesser towards the iodine nucleus. Okay, so if it is iodine is a larger anion, so the bonding electrons are present in the outermost cell. It should be attracted very lesser towards the iodine nucleus. But in case of aluminium, you see, aluminium is a highly positive charge piece because it has a 3 valency. So it should be attracts the shared pair of electrons towards itself. Okay, so then what will happen? Automatically the iodine, it leads to insufficient charge separation for it to be ionic. So it results in the development of covalent character in aluminium iodide. Are you able to follow me? Actually, aluminium triiodide is a ionic compound. By sharing of by transfer of electron only, it should form the aluminium triiodide compound. But because of the larger anion, the the nucleus of the iodine could not attract very heavier in the outermost electrons, that is shared electrons. But at the same time, it has a larger aluminum have a 3 positive charges. These positive charges attracts the high positive charges attracts the shared pair of electrons towards itself. So the charge could not be separate completely. Okay, there is no more charge separation here. So it development of covalent character in that compound. So aluminium triiodide is an example for covalent nature. Okay, is an it could be explained by the Fajan rule. Okay. Yes, the following diagram should show the separation of ionic compounds. Okay, so here you see the same anion should be used, chloride. Different types of cations are used. Here this side same cations are used, different types of anions are used. So based on this, you can identify from the top to bottom, the ionic in the left hand side, the ionic character should be decreased. On the right hand side, the covalent character should be increased. Okay, so sodium and chloride, it's a fully ionic compound, but in case of aluminum and chloride, chloride, it should be formed by ionic compound, that is transfer of electrons, but actually it shows a covalent character because of the large anion and high positive charge. Okay, so similarly aluminum fluoride, it shows a ionic nature, but at the end aluminum it is aluminum bromide, it shows a covalent in nature. Okay, so these are the some compounds formed ionic bond, but it should be shows a covalent reason. This was explained by the scientist Fajan in the year 1923 by his X-ray crystallographic studies. Okay, hope you all are understand this lesson. Go through your book. Meet you in the next session. Thank you, students.